Recap of what we talked about last time, but the topic over this series is DevOps and Epic Tale, because there's a lot to this, and I got to admit that there's no way we can do this justice in an hour every month or whatever, right? The idea here is to present big ideas, right? And kind of, if it's new ideas to you, to kind of whet your appetite and get you thinking about things, introduce you to some things and some ideas, right? But by no means do I call this training or like exhaustive, right, everything you need to know type of information. So take what you can get out of it. The topic is DevOps in a broad scope. And we talked about last time, the practice of DevOps is really, it's about agility, right? It's about developers and operations staff working together and collaborating to create agility from sort of inception of an idea to delivered software and then the ongoing monitoring and maintenance of that software, right? How can we create agility in that space? Not really about tools, although we're going to use tools. We use tools, right, to support these kinds of ideas. But the bigger DevOps idea is really more of just an idea and a theory. So last time we talked about containers, if you recall. And containers, we talked about where they fit in this DevOps lifecycle, and we really focused on the packaging area. How do we package software such that we can more easily and more reliably deliver it to various platforms, right? So we talked about why we use containers, what they are, and the idea here is really portability, right? How can we build applications that will run in this environment and that environment the same, right? Because we have this age-old problem of we deploy our code to the development environment in any given enterprise, and then we move it over to the test environment or the QA environment, and it doesn't work the same. Right? There's either configuration differences in that environment. We've got machine, right? Hosts are different. We've got IP issues. We've got firewalls. We've got all these things, right, that can come up in that delivery cycle. So this idea of containers is to package an entire application, and it's supporting operating system, drivers, configuration, policies, security. Everything that it takes to run that application is in this container or this image, right? And the idea here is agility. We want to increase that agility and remove sort of these barriers that we have in the enterprise oftentimes of deployment across environments, right? So it's the idea of build, share, run. I build my application into some structure, a Docker image is what we've been talking about. I share that in some way so that I can access it across different environments, and then I run it. And the guarantee in the Docker world is if I run it, if it runs in this environment, it's going to run in this environment the same way, right? That's what we're looking for. And the DevOps friendly part of this is, and this is sort of broad strokes, right? All enterprises are different on how they divide teams and manage their staff. But typically, or kind of at a broad stroke level, developers own the inside of the container, right? The application code, how it's written, how it's configured, how it's deployed, right? And the operations handles the outside or the container itself. What OS it's running on, what policies of that OS, what security constraints, how we monitor that, right? All of those types of things can be done on that same unit of work. So that's real quick then, just to sort of try to cement that a little bit. And again, can't be exhaustive here in the time we have, but what we want to look at here is, I got a simple .NET application here. Close that up. Right, and it's basically just a REST service that answers hello to whatever name you pass in, right? Simple REST API. If I say API hello and give it a name, it's going to kick that back out to me and say hello, blah, 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 right? Whatever I sent in. Pretty simple application. I can run this using the .NET SDK right here, just like I would in my normal development environment, right? And it'll run. There it is running on port 5000. If I go over here, and I go to my local environment, Insomnia, and I run .NET, you can see I can say, hello, Jaime from .NET Core, right? Pretty simple. Nothing Docker or interesting about that, just that I have this application developed now, right? So if I kill that, I can now, using the Docker CLI, if you recall from last time, and those that weren't here, I can say, I want to build an image, I want to tag it simple .NET service, and I want to build it off my current directory. This is Docker taking that application code and applying. Let that finish so you see what happens there. All right, so it's done. Probably should have showed you this first. Here's a Docker file. So in Docker, if you recall, we give it a set of instructions that indicate, way too big, indicate how we want to build this application into a Docker image, right? And a Docker image, again, is just it's a vehicle for packaging an operating system, all the tools or software necessary to run my application, and any policies I want to apply to it. So you'll see this is multi-stage. Can't review all that today, so I apologize for that. If you want to talk Docker with me, ping me anytime. I'd be happy to sit down with you. But this is building from the SDK, right? It's going to go through and do my .NET Restore to build my application. It's going to copy that in, and then it's going to take a runtime image, removing the SDK, right, from that image, because my runtime, I don't need the SDK. I just want my runtime artifact. And it builds that, exposes a port, and kicks it off here with a .NET run on my DLL. Now if I come here and say Docker run, leave that there for a second. I'm going to say Docker run, RM basically says just destroy the container after it runs. Expose a port, 5000 from 8080. So if you remember my Docker file, I said I want to run this on 8080. Locally, I want to hit it on port 5000. So I'm going to run it there, and I'm running my simple .NET service. So if I run this, we should see exactly the same thing happen. Except now I'm not using the .NET SDK to run the application. I'm running it through that Docker image. If I come back out to my REST tool, you'll see I can hit the same thing. Big ideas, right? A lot of details in there I skipped on the recap, but trying to catch you up on just the whole container idea. So now let's move on to next topic. So next topic is orchestration. And this idea is really about how do I do this at scale, right? So it's easy enough, as you witnessed there, to build a Docker image, run a Docker image, right? Manage that individual container on just with my CLI. But we talk about dozens or hundreds of these things in an enterprise, right? I don't want a bunch of guys or operations staff sitting around on a keyboard typing Docker commands to manage these large applications at a scaled level, right? So orchestration in a large sense is really just a process or an idea of managing this kind of container development at scale, right? Once we get outside of my little machine Docker running here, how am I going to interact and deal, understand how it fits into our release, configure, monitor phases of DevOps, right? So I've packaged this thing as a Docker image. How do I release that, get that, or provision it into an environment? How do I configure that environment? And look at the configuration of that environment, and how do I monitor it over time, right? So that's really where orchestration comes into play. You see my three little icons up here. We're going to talk about these three things today that fit into this space. So the big ideas of today's talk are, we want to remove the traditional server environment mindset when we get to this world, right? So what I mean by that is, if you think about enterprises we've all worked in, they typically have a development environment, and along with that development environment, they got a set of hosts, servers, right? They got 16 servers or whatever number. That's our development environment. Whether that's virtual or real, doesn't really matter. They've usually got some set of scripts and a bunch of guys that know how that environment's configured and run. When you need to change it, they go out and they do some stuff, right? And they change that environment. Then when you go to the test environment, they got another set of servers, right? And probably the same guys, but now we're reliant on the fact that, well, this environment has to look the same as that if we want reliability, and it rarely does. No matter what they do and what they say, right, it's almost always different. So we want to get rid of that mindset of environments being a set of servers and hosts, and just say, I've got this ecosystem of servers available to me, right? And I can just deploy my code, and my orchestration platform is going to figure out how to do that and how to land that for me. It's going to give me ability to separate environments. Gets me out of the mindset of thinking about what host I'm landing on ever. I don't really care what host I'm landing on, right? So that's the first big idea. Good with that? Second big idea is making the provisioning and deployment cookie cutter. And there's a couple different levels to that, meaning it ought to be super easy, right? It ought to be repeatable, and it ought to be the same for every environment, right? When I'm deploying something to the dev environment versus the prod, ought to go through the same process, right, or the same general process. And I want to be technology agnostic in that cookie cutter approach. So if I'm deploying a .NET app or Spring Boot Java app or a Go app or a Node app, I want to use the same basic process, right? And that's what Docker is allowing us to do. If I can get to a Docker image, Kubernetes, OpenShift, Cloud Foundry don't care what's in that image, right? They're just going to provision it and run it based on how that image is set up to run. And obviously, automation is a key characteristic of this, right? We want to automate this so we don't have monkeys on a keyboard slapping keys to get this to work. Platform features that we would look for, and this is not an exhaustive list, but sort of a representative kind of high-level things we want to look at. So we want to look at computing resource management. So our platform should give us that, right? And what I mean by that is I again, want to get out of that mindset of I know what servers are out there to run. I just want to know there's a platform maintaining a set of servers, virtual or otherwise, that will support my applications, right? I need some hosts, basically. And I want to be able to add and remove, scale up to more hosts, remove hosts, and have the platform take care of that for me. As a developer, as an operations staff, all I care about is how do I provision into that environment, not what all makes up that environment, right? Big or small. It ought to do that provisioning and deployment. If I say I got this new app and I want it to go out, how do I do that? Well, the platform should give me capabilities to do that, and we'll look at that today. It should manage availability and redundancy. So how many containers do I say I need for any given application, right? How do I know when they're alive or dead? What happens when one dies, right? Does it manage the availability and bring one back up for me? Yes, the answer should be yes, right? I want my platform to take care of that for me. So kind of anecdotal case of this is if I have a orchestration platform that has, let's say, 4 hosts in it, and I've got applications deployed on there, and some are landing on each host, right? I got 2 on each host, let's say. And one server dies. Hardware, network, whatever the reason, that server dies. Somebody tripped over the cord, right? Comes unplugged. The platform should take those containers and drop them onto another host that's available for me, right? I shouldn't have to go fix that and say, well, we had 2 things running over there. That server died. Now I got to go manually take care of it and get it onto this new host. The platform should do that for me. So that's this bullet. It should handle load balancing. So as I scale horizontally my applications, it should give me a mechanism for load balancing across those containers automatically, right? Which most do. Endpoint exposure. How do I expose endpoints to the outside world versus keeping things internal to the platform? All right, and then monitoring. How do I look at that platform, understand what's going on, right? Because the reality is there's still got to be some operations staff managing this platform, right? But it's not the same guys that are managing the day-to-day deployments, application rollouts, monitoring of application level stuff, right? It's a different role. Cool? So the first one we want to look at is Kubernetes. What is it? It's an open source container orchestration platform developed by Google in mid-2000s, 2010s, 2014 to be exact. And now it's maintained by the Cloud Native Computing Foundation. It's implemented in Go. I'm going to be super high level on this. Kubernetes is implemented in the way that they deploy environments by what they call clusters. Okay, so we're going to take a set of hosts or servers, and we say this is our Kubernetes cluster. It can spread itself across these nodes or these hosts, right? And there's more types than this, but there's 2 primary types we're going to talk about today. The first is it works in this sort of master-worker or master-slave mentality. So it'll have a master-slave that's the primary controller of the Kubernetes cluster, and that's responsible for maintaining the state of the cluster. So if I say I want these 10 apps deployed onto this cluster, the master's job is to make sure those 10 apps are deployed on some set of worker nodes at all times. Right? If one worker node dies, he's going to take care of getting it up on another one. If I want to communicate to the cluster and say, I need this application deployed, I communicate with the master. Right? So I'm always working through the master. In fact, I don't know or care or want to know how many of these they are and where they live. I want the cluster to take care, the master to take care of that for me. Right? So obviously then our workers are responsible for actually doing the work. This is where our workloads get deployed and provisioned. Right? The master will schedule a job onto a worker. The workers all have Docker installed, Okay, this is all based on Docker. Kubernetes is a Docker tool. And the worker will get scheduled. He'll go through the process to stand up that Docker image as a container on the worker node. There's some basic resources that are in Kubernetes. This isn't, again, an exhaustive list, but these are the kind of, you need to know this to even start kind of ideas, right? So the first idea is this idea of a pod, and it's really the smallest deployable unit in Kubernetes. So when I deploy anything, if I want to get an application to run or a Docker container to run, I have to do that through a pod definition. And it's really, you can kind of think of it as a one-to-one with a container, but I can run more than one container in a pod. And there's reasons to do that, which we can talk about afterwards if you care. But typically you can think of, just in your mind, a pod as a Docker container. So just like I ran my .NET app there in a Docker container, that will be a pod in Kubernetes. Inside of that pod, which is really just this idea, right, it's really just running containers and managing those. Next idea is the idea of a service. That's where we pick up the load balancing, right? This pod is my scalable unit, right? So if I run my .NET application, my simple .NET service, and I spin up one container or one pod, right? And now I want to access that. I could access that directly to his IP address, to that pod's IP address if I want. But I really shouldn't do that, because what happens now when I spin up a second one? All right, now I want to load balance across those two and have availability to both. That's where this service idea comes in. It defines a internal load balancer, and I use the word internal for a reason I'll explain on the next one, is all my access to pods should go through a service. So if I have one service, one application talking to another application, I don't go pod to pod, right? I go through a service. And that service will look at, there's various algorithms you can use, most available, round robin, custom load balancing policies, right, to say how I want to spray a load across these things. But the fact is I still go through this service. Okay? Next idea then in Kubernetes is Ingress. This service is only internal to the cluster. Okay, and this kind of exposes a big idea that I didn't hope to say, but now as I start to explain this, I'm going to have to say it. Kubernetes manages your whole network stack as well. So when you install a Kubernetes cluster, it will take whatever IP range that you set aside for that cluster, and it will put an overlay network over the top of that existing on-prem network or virtual network, right? And the reason I'm saying all that is once you're inside that cluster's network policies, nothing can get in or out of it by default. Okay, it's an isolated cluster until I introduce this idea of Ingress. Okay, Ingress is exposing things allowing things into the environment, into the cluster. So if I stand up my .NET application and I don't expose an Ingress point, I could hit it as long as I'm on the Kubernetes network, the overlay network, but I couldn't hit it from the internet or from outside the cluster, anywhere else on my network, right? Make sense? So that's Ingress. And then the last one is namespace, which is just used, it's a logical separation idea. It's establishing boundaries around applications, okay? So within the cluster, if I want to separate things by team or by types of application or by their function, right, I can do this however I determine that necessary, but it gives me a way to logically separate applications so that when I log into a cluster or connect to the cluster, I don't see 100 applications, maybe I see 10 that are related, and 10 that are related, or 10 that are for one team, right? Or how we typically use it, we do it by environment. So if I have, back to my enterprise environmental idea, if I have a development environment and a QA environment, and a staging environment, and a production environment, those would typically be separated by namespaces, right? So I might have the same applications running in prod that I have a new version running in QA. And I want to be able to separate those things logically and physically on the network, right? So namespaces, once we introduce OpenShift, Kubernetes doesn't do this by default, but once I introduce OpenShift, it gives me the ability to isolate these on the network also, and by role-based access, yes.
So you wouldn't have different clusters for different environments. You would just like kind of cordon them off with namespaces like this.
You get to choose. Okay. You get to choose.
So
what I've seen in practice is we have a non-prod environment and we have a prod environment, right? So non-prod is dev, QA, staging, blah, right? Anything that's not prod,
Yeah.
experimental, right? We have things like that in there. And then prod would be a separate cluster, right? And they want to do that for more network isolation. Right?
You're dividing that by, those are each one cluster? You're prod and non-prod in that case? Or
Prod and non-prod are clusters. Dev, QA, staging are namespaces.
Inside.
And then inside my prod, I have one namespace that represents whatever, like if it's dev, I'll use a team we have there. IT Web is a team. We have an IT Web development namespace. We have an IT Web QA namespace. We have an IT Web experimental namespace. In prod, we have an IT Web namespace, right? Because all their apps drop into one namespace in prod. Does that answer that?
Yeah, that's great.
Do namespaces do anything other than logical organization, or is there like a physical routing, load balancing advantage to that, or is that just?
Not in Kubernetes, but OpenShift builds on this idea, which we'll get to in just a second. So in Kubernetes, it really is just a logical boundary. One app in one namespace can talk to another app in another namespace by default, right? OpenShift gives me the capability to isolate those.
One more question real quick. So just to get my mind clear, this slide effectively highlights a cluster, multiple pods. Would you typically only have one service and one ingress, or do you have multiple instances of those as well, and like load balance across services, for example? Or is it typically one-to-one service ingress to a cluster?
One ingress, typically. One ingress, one service, multiple pods.
Typically,
yeah. Yeah. The times we've done different is that if I'm exposing multiple ports on an application, I'll have two services because a service is bound to a port. Okay? So a service is always saying, I'm routing from this port to this port on these pods. If I got another port, I need another service, right? So if you had JMX or some kind of other routine that you needed to get access to, you would have a different service. But at the port level, it's one-to-one.
and that's a cluster port level.
No.
Sorry.
No.
I don't want to take you too far off track. I was just curious.
It's an application. So every pod. This is a little deeper. So
you can say we'll talk about this later. It's okay.
I'll just say this briefly. Every pod gets assigned its own IP on the overlay network, right? It's an internal to that network. Doesn't really apply to the IP that goes to the whole cluster's outside real world, right? And every service gets an IP and a DNS name, because there's also DNS that has to route. That's how this works, right? So every pod owns its complete namespace because it's got its own IP. So if I stand up my .NET service in one pod, it'll get an IP. If I scale it up to 2, and I can show you this here in a minute, I'll get another IP. They're both running on 8080 because they manage their own port space because they have their own IP, right? So I really never have to, like today, in a traditional world, if I had a server and I had microservices, I got to make sure that I don't have the same port attached to multiple applications, which is a real hassle when you get scaled, right? This removes that because every pod gets its own IP. That make sense?
Yep.
So sometimes a picture is worth more than 1,000 words, right? So here's basically that last slide in picture format. You can see here I've got multiple masters. Okay, I can have as many of these masters as I want. I'll talk about why you would do that here in a minute. And I can have multiple workers. Okay, within the worker, you'll see that I've got Docker on every worker. These white boxes, run out of space for words here, but these white spaces are namespaces, right? So these two pods are living in one namespace, these 4 are living in another namespace. So this is kind of how it's logically separated, right? These YAML files, which we'll deal with here in a little bit, are how I will instruct Kubernetes to do things, right? I'm going to write some configuration through YAML, some instructions. I'll ship that over to the master. The master will then schedule that stuff down through this kubelet API to the workers. You don't really need to know this for it to work, but I like to understand how it's really working, right? Because things go wrong, right? Things go wrong sometimes. You've got to figure it out.
So is kubelet just an API, or what is it exactly?
It's just the control application for the worker. It's the thing that this API server knows how to talk to, right? So when he gets ready to schedule a job, he will always go through that kubelet proxy or daemon. There's a daemon running there, right? I'll go ahead and say this, and then I'll show you on AWS once we look at this. So typically you would scale these things, right? So let me back up a second. So the way I've installed this for today's demo is on AWS. Right? So I took AWS EC2 instances, I allocated some set of servers, and then I spread that load across masters and workers, which we'll look at. The reason this is really nice is I can put a master in one availability zone and put another master in another availability zone, and then spread my workers across availability zones. For those that don't know, availability zones give me the capability of losing an entire node but not losing my entire cluster, right? If I was to drop all of these into the same AWS availability zone and that availability zone went down, I lose my whole cluster, right? But if I spread it across availability zones, then I don't have that risk. And availability zones manage their own network, their own power, their own data center, right? They're completely, at AWS, they're completely separate entities running on different grids, right? So the chances of losing multiple of those at any one time is not high. And I think each region offers 3 availability zones still, right? A, B, and C, typically, which we'll look at in a minute.
Could you run it on Azure and Kubernetes?
Sure. Yeah. Yeah. And we'll talk about Cloud Foundry. Cloud Foundry's got Kubernetes support now too. So
Okay.
this is not isolated to just raw Kubernetes, which is what you're going to see as we come up here. Here's an example, and I won't spend a bunch of time here because I think we beat this one to death, but this is what Ingress looks like, right? Outside world comes through an Kubernetes Ingress, gets a service, sprays it across some set of pods, always, right? This is all DNS based. So when I create a service, I will get an IP for that service and an internal DNS name. And there's a DNS router living in the Kubernetes networking world that'll get published. Then when I expose this, I'll get another DNS entry for this. That DNS entry is what I'll communicate with the outside world. He'll then spray it over here and so on.
I'm assuming just for like internal pod-to-pod communication, you just use that internal DNS?
Yes, I would always use this service.
Okay.
Yes. Now typically you wouldn't go pod to pod in the same pod, but I might go pod to pod.
Yeah, that's what I mean.
Because this is going to be in process.
Since there's no like service discovery happening there, you just
Yeah, so he would go here, right? Pod service here.
Yeah, but there's not a way to discover that service. You just have to know the DNS.
You know the DNS, yes. Yes. And it's based on convention, right? You can create your own DNS convention, or Kubernetes will, if you just say create a service for this, it'll give you one by default, and it's always going to be based on pod name, namespace, .svc.local, and then whatever port you've exposed. All right. If I got this cluster now, how do I tinker with it, right? I use either a CLI, kube control is the name of the CLI, the command line interface, or there's a web console that you can do limited things in Kubernetes. The Kubernetes console is somewhat primitive and is really intended to be CLI based. You can do some things here and it's getting better all the time, but this is more view, administration, monitoring, looking at stuff. Interactions typically done through the CLI. Next topic is OpenShift. What is it? It's obviously a container orchestration platform as well, or we wouldn't be talking about it. It gives you 2 options. It actually gives you more than this, but 2 that we care about really. Open source version, which is full-blown OpenShift, right? Really not limited in any way other than support. And then an enterprise version, which is supported. It's the same exact code base. They release slower to enterprise because they do go through more rigorous testing and validation, right? So this is going to be ahead of, just like every other product we deal with, right? This is always going to be ahead of breaking features of the enterprise supported version, but they're both there. It's a Red Hat tool. It's built on Kubernetes. In fact, it is Kubernetes, right? They like to call it enterprise Kubernetes, and they call it that for these 4 reasons. It gives you some of that which we just hit on, this multi-tenant capability, right? So if I've got multiple tenants, whether those tenants be different teams, different companies, different guys on the same team, however you want to set those up, basically I can separate my namespaces by tenant and give role-based access to those things. And now if guy or gal on this team logs in, they see one set of things, same cluster, somebody else logs in, they have different roles and access to namespaces, they only see their stuff, right? So it gives us that sort of enterprise isolation and multi-tenant capability. It also separates the network, or gives you the option to, so that one namespace can't by default talk to another namespace. You have to explicitly open that up, which is important in the multi-tenant case, right? one team says, well, I don't want anybody else in here, then you just turn that, or don't turn on the ability to do that across those namespaces. It also integrates native CI/CD capabilities into the platform. So I didn't say this, I should probably put this on the Kubernetes slide, but Kubernetes starts with a Docker image. Until I have a Docker image, I can't really interact with Kubernetes. There's nothing it can do to build it for me, to run a pipeline, to get any kind of image into any kind of state to run. I have to have the image and then provision it into that environment. OpenShift gives me those native CI/CD capabilities to build images and run pipelines to do unit testing and quality and vulnerability scans. And everything I would want to do in a typical environment is native to OpenShift, so that's built on top. And then it simplifies installation and maintenance. Kubernetes is really, really complex once you get out of the normal go through the tutorial, install it phase, right? If you really want to install it in an enterprise, it's pretty hairy. This, still hairy, just less hair. More like a crew cut instead of a, right? So, still not easy. It's all relative, right? Still not super easy, but again, once you get outside of the simple case, but greatly simplified, and version 4 came out 2 or 3 months ago, maybe. It was released. They've severely improved this process, and they've got a new strategy for how they're doing this, so it's getting better all the time on sort of that ongoing, especially in the ongoing maintenance, right? When I want to upgrade from this version to this version, or I want to add nodes into my cluster, or I want to change my DNS configuration, right? Those things are getting easier all the time.
Quick question for you on CI/CD. So a lot of organizations already have some CI/CD in place before they ever get to this world. Do you find most of those organizations swapping from their current setup to use OpenShifts, or
if they're Jenkins-based, yes. If they're not Jenkins-based, this is Jenkins-based, yes. So it integrates Jenkins natively. If it's not Jenkins, no, they stick with what they have and just integrate through their own. Yeah. So how it works, the basics. Again, basics, not an exhaustive list, but the things you need to know, again, to use OpenShift. First idea is, well, first off, everything you did in Kubernetes applies here, okay, everything. The same templating language I use to process things with kube control, I'll use in OpenShift. Same exact thing, not different. But then it gives me these extra ideas of a build config. Basically, how do I get from my source code to a Docker image, right? That's as simple as I can say it. Gives me this idea of a deployment config. How do I get from the Docker image to a running container and then maintain that state? How many instances do I have? Do I want, what kind of strategy do I want for rollout on here? Those types of things, right? With OpenShift and Kubernetes, I have this idea of a rolling deployment, which is basically a zero downtime deployment. So what, again, in a nutshell, I can only give you the nutshell version today. In a nutshell, if I have a running container for this application and I say I want to deploy a new version of it, it will spin up the new version in a container, leaving the old one there, still sitting behind my service, right? So all traffic's going there. It'll spin up the new container. It'll check whatever readiness and liveness probes, which we haven't talked about, but you get the idea that it's got to know when it's ready to serve traffic, right? And then it will drain the traffic off of the old pod, and then it'll swap in the new pod and point the service to the new pod, right? So essentially I end up with a blip, usually, of service down. If you do this in a scaled fashion, right, I don't do them all at once, then I have true zero downtime, right? Because I'm always going to have at least one running, because it will swap them in one at a time. If I only had one, then I'm going to have a split second of that service being switched over. Next idea is route. This predated, so OpenShift started out, they were non-Kubernetes. They had a cartridge model, and they kind of implemented their own way to do this orchestration. Kubernetes got a big head of steam, and OpenShift saw the writing on the wall and said, we're screwed if we keep doing what we're doing. We got to get on the Kubernetes train. So they jumped on Kubernetes pretty early, before Kubernetes had an Ingress option. And they defined their own called a route, but it's basically the same idea. How do I allow external traffic into this environment? And you can use Ingress in OpenShift because it is Kubernetes, but most people use routes because it's the native thing to OpenShift. And you get visibility into it in the console. When you look at the console, you won't see Ingress as easily as you'll see routes. And then we talked about this first-class support for CI/CD pipelining. How do I interact with it? Same as before. I get a CLI. The CLI is OC, and I have a web console. The web console in OpenShift is pretty good. Right? It gives me access to do most things. There's some administrative stuff you can't do, but for the most part, everything I can do in C and OC, I can do in the web console. Last topic is Cloud Foundry. I'll caveat this with saying I don't really have any great experience with this. I've done a few things. We did some work with Cloud Foundry. It was really my first exposure to it, but it's super basic and simple just to get things running. I've since tinkered with it a bit more, so I get the idea, but I don't have a lot of deep experience with it that I can share. But I just want to share this, I want you to keep this orchestration ideas. This is a big idea, right? And there's a lot of options in this space, and as long as a platform provides what any company needs, it's a good option for them, right? And there's advantages to using this over OpenShift in some circumstances, or Kubernetes. And there's other advantages going the other way in some circumstances, which I'll try to point out. So Cloud Foundry is a platform as a service. It is a container orchestration tool as well. It gives me deployment, management, continuous delivery type behavior. It also has an open source version called Cloud Foundry and an enterprise Pivotal Cloud Foundry. Also IBM Bluemix is a Cloud Foundry implementation. There's several others that I didn't put on there. It was developed by Pivotal in 2011, so they predate Kubernetes. They were doing this before Kubernetes, and therefore they're not by default Docker Kubernetes based. They run containers in something called Garden, which is just another container platform. And the later versions support Kubernetes natively and Docker. So.
It's interesting that IBM bought Red Hat, but
And they have a Cloud Foundry out there.
they had Foundry at first, but I wonder if they're going to move.
I don't think so, because I think they serve two different audiences. OpenShift and Kubernetes are much more scalable and customizable than Cloud Foundry. Cloud Foundry, and it's coming up here on the slide probably, is more geared towards simplistic, I just want to get it to work kind of model, right? So if I have a Spring Boot application, you'll see when I actually run through this in demo, I don't have to give it a lot of configuration to stand up an application. I basically specify a build pack, which I think is on here, and I push it. And Cloud Foundry takes care of building the container, scheduling the container. I don't really have, by default, much control over how that container is built, what's in it, what kind of vulnerabilities it has, right? I have to get much deeper into it to get to those types of ideas. Some enterprises would be happy with that.
Yeah.
Some wouldn't, right? Because most network engineers and operations staff want to know exactly what OS is running, exactly what patches have been applied, exactly what ports are exposed, what policies are there, how's it running, is it running as root, is it right? They care about all these things, right? Cloud Foundry simplifies all that, takes a very opinionated approach. So you'll see here when I do this, if I say deploy my .NET app, I just say deploy it, and it magically goes and does its thing, right? And it deploys it. What it did, I don't know, right? Did something. And we could figure that out, but the idea, I think, behind Cloud Foundry is you don't care, right? If you care, it's probably not the right choice.
More like Heroku or something.
It's more like Heroku, where it just does it, exactly. So it has a cloud controller that runs the application, decides where to provision it within the infrastructure, much like the master in Kubernetes, and manages its life cycle. If it dies, it restarts it, right? If a node dies within the Cloud Foundry cluster, then it'll restart it on another one. Does the same sorts of things. Gives me load balancing automatically in front of my scaled applications, and automatically exposes every service by default, although you can eliminate that or remove that or change it if you want after the fact. But works much the same way from a idea standpoint. I interact with it through a CF CLI, or they also have a web console. We'll look at both today. The fun part, the part that everybody cares about. All right, so we looked at our simple .NET service. We ran that as a Docker container, right? So we know we have this application, right? I want to take this application, I want to deploy it onto OpenShift, and I want to deploy it into Cloud Foundry, and then just talk about how that's done and the differences and kind of walk through that process. Before we do that, let's look at our cluster. So this is AWS EC2 console. You'll see it here, I'm running in the Northern California region because that was the only one we didn't have crap in. And you'll see here I have 3 masters and 3 workers. All right. My masters are spread across availability zones 1B and 1C. I actually have 2 on 1B and 1 on 1C, right? Same with my workers. So this is just demonstrating that idea of I got this is my computing power, right? This is the resources I have at hand to deploy whatever applications I want to deploy out to it. So if I lose 1C, then it's going to take whatever's on 1C and it's going to schedule it onto 1B for me, right? If I scale in OpenShift, Kubernetes, to be honest, I can't answer this question. It may or may not do this automatically. If I have like my .NET application and I run one instance, it's going to choose which one of these availability zones to launch it on. And it does that through labels that are attached to these Kubernetes nodes, okay? If I scale it, it's automatically going to put it in the other region. If I got a third region, I scale it up to 3, it's automatically going to put it into the other region. That way I always am spreading my load across whatever availability zones I have. Does that make sense? So I don't have to physically, again, the idea of this is I don't care, right? I just want to push a button or give a command or auto scale it. And when it spins up, it just knows, oh, I got one here. I don't want to put another one there. I need to put it over here, right? So this is just showing you that. So let's look at, this is my console. When I log in, it drops me into this view. A project in OpenShift is a namespace in Kubernetes, okay? It's a namespace with some stuff. And the stuff it gives you really is that role-based access and the ability to separate my network policies, right? But in practice, it's the same thing, right? So these are my namespaces. You'll see here I have a CI/CD namespace, development namespace, QA, and a staging namespace, right? So I've separated, this is the way I decided to do it, right? If I click into development, you'll see I have 2 applications here, Simple Go service and a Simple Spring Boot service, okay? We're going to install our Simple.NET service here alongside these. If I look at these guys, you'll see I have one pod running. We'll go look at him in a second. And my update strategy is rolling, so I can get that 0 downtime deployment. When I deploy, it will do that rolling deployment that I discussed. I'm also getting some other attached resources here. So I have build configs, my service, this is my load balancer that we talked about, and my route. Right? If I don't have a route, you're not going to see one here, but I expose this so I can get to it from the outside world. My service is saying go to port 8080 on the pod. If I look at the pod, here's my one pod I have running. You'll see he gets an IP address, right? And it's got one container running in it. This is Docker container right here, right? So if I go into here, I see everything about my Docker container, right? My logs are at a pod level, right? And if I had multiple containers in here, I'd have multiple choices for which container to look at. I can terminal in here, right? And do things with my service if I have the right access to it. But this is my running application as a Docker image, a Docker container in OpenShift. If I look at QA, you'll see QA, I only have the Spring Boot service running. So it's a separate namespace. This is a separate version of the application that's now gone to QA, right? Development can continue. I can keep building development images over here while I'm building QA images over here, right? Fixing bugs, going through that process. Ultimately, I would take this image that gets QA'd and promote that to production through a process, right? I wanted to show you scaling here. So I can come here. Actually, I want to go overview. If I do this through the interface, I can come here and I say I want to scale this up to 2. Right, now I got 2 pods. Second pod, let's actually go back there. Container's creating, right? So it's starting up the container, now it's running, right? If I go back to my project, you'll see now I have 2 of 2 pods running. So I've scaled that again. I got that service sitting in front of it. If I were to go hit this, and I think I got a load balancing round robin approach, so I'm hitting one server, other server, one server, other server, one server, right? That makes sense? All right. So let's talk about how this gets here. So let's go to VS Code real quick. We looked at our Docker file. You'll see here I have a file called OpenShift template. And in here, I got a bunch of stuff. Can't teach you this today. Keep the big ideas, right? The idea is that I want to tell the CLI and ultimately the master how I want to provision this application, right? So we have our build config we talked about, our deployment config, a pipeline, a service, and a route. Don't worry about image stream, different topic, different day, okay? But it's in there too. So if I look at any one of these, I look at my build config, let's say. I want to build my simple.NET service, and here's my Docker file, right? So I'm telling that build config, here's the Docker file I want you to run. This looks exactly like the Docker file, obviously, that I ran on standalone earlier, right? So that's sitting in there. If I look at my deployment config, if I close up the right stuff, my deployment config, so how do I get from image to a running pod, right? And the important parts of this are, I want to run this image, I want to expose this port, I want rolling strategy, there it is, rolling strategy, right? How do I know when it's alive? How do I know when it's ready? All kinds of things I can put in here, right? But the basic idea is how do I get from the image that I'm producing from the build to a running pod? And then pipeline. This is a Jenkins file pipeline. So OpenShift integrates Jenkins by default. It also has extension hooks to build any kind of other CS. So if you wanted to use TeamCity or Bamboo, or so you could build, I haven't seen any, but you could build an interface into OpenShift to do the same sort of thing. But by default, you get Jenkins stuff. So here's my fetch source stage. If you're not familiar with pipelines, it's basically just this idea of building a process through a configuration file of how I go from one state to another. And in this case, I want to go from source code to running pod. That's where I want to get. In between, I can do whatever I want. I want to fetch the source. I want to build an image. I want to deploy, right? I fetch source. I do some unit testing, right? If my unit testing fails, I never build the image and continue. If it doesn't fail, then I build the image and I continue, right? So you get this idea of I'm in complete control of what happens here. We do things like vulnerability scans in here, right? Quality framework, static code analysis, all kinds of stuff like that, right? We can put into this pipeline, whatever we want to put in there. Let's go back here to status, so when I kick this thing off. And I think that's probably enough about this, and my service and my route, uninteresting. Port 8080 is going to this deployment, right? Simple.NET service. Route, giving me a DNS name for that service, same idea. Big idea here is I create some configuration, I come out here to my environment, I make sure I'm in the right project or namespace where I want to be. I say OC apply, -F, OpenShift template, and it's going to go create all these things for me. If I go back over here, you'll see now I have a simple.NET service sitting here, right? No pods running, and I could have made that part of my deployment process, like go ahead and kick off everything. But typically that's not what you would do, right? You would go through a provisioning stage, and then I would come out here and I would write some code, right? So if I came here, let's put some extra emphasis on this because it's really cool. And now let's actually do it through here. I go here. I deleted some stuff I don't care about right now. My only change is I added an exclamation point. I'm going to commit this, added emphasis. I'm going to push this up. And what I should see happen over here, if I go to the right window, is in my build config, pipeline, .NET, right? I got one running here, right? And if I look at this, you'll see it go through this process, right? So it's going to run my pipeline, do my build. I don't think I had testing in this one. I'm going to build my image and then deploy it, right? This will take about 3 minutes to complete because it's got to go through the Docker build and the deployment process. So we can sit here and watch it. I'm just kidding.
Those Git hooks
No need to
were
watch.
native. You didn't have to turn those on.
You do have to configure.
You do.
So it depends on your source repository, right? So in GitHub, everything's webhook driven. So in GitHub, I'll just show you here. If you go back here, and they've changed this interface in 4.0. So you see here, I put in my GitHub webhook URL. So I went to GitHub, generated a webhook, or I actually grabbed this, go to GitHub and input this into the webhook and tell it when I want it to happen. So this is all with GitHub and GitLab, it's all branch-based. So if I'm building multiple branches, like a lot of times my development branch will be different than every time, will be different than my QA branch, right? If I trigger a code commit to QA, it's only going to run the QA pipeline, right? If I do dev, it's only going to run, it'll discern that for you.
Can you source control the build configs?
Yes, and that'll be a topic for next time. We're going to talk about automation and so this is kind of how the bare bones of how I interact. how do I automate this and manage this at scale, right? Because I'm going to have lots of these OpenShift templates, right? And I don't want to put all those in. I don't want to have an OpenShift template in every project because a lot of times they're exactly the same or very close, right? What if they want to change? I don't want to go to 50 files and update them, right? So we're going to automate that process too. So here we are building and so on. So if I go out here, you'll see if I run .NET, it should fail here until it gets deployed. While that's running, let's talk Cloud Foundry. Much simpler. If I want to change things like this and give it a nice name, I have to give it a file here. But it will just look, it'll introspect the application, Spring Boot, Java, Go, Node, and it'll just pick a build pack and do it, right?
You mean you don't need a manifest file at all?
You don't need a manifest file at all. Yeah. And you can specify all of these things on the command line too if you want. You can use a -F for, or -N for name. I think it's -B for build pack. Right, so I have that file. It's actually before I kick it off here. Let's go over to Pivotal. This login usually fails the first time, but it didn't because I said it would. So this is Cloud Foundry's web console, right? You'll see here we have a couple different organizations. So they've got this multi-tenant idea where you can separate things, role-based access, and separate at an org level. If I go into us, then I have this idea of spaces, very similar in nature to a namespace or a project that we talked about in Kubernetes, right? So this is my development namespace. You'll see I have Go and Spring Boot running out here, right? And if I look at these, you'll see I can see information about it. I can enable auto scaling. I can look at the settings, look at the logs, do things with route, right? Get some basic up. I can restart it, right? There's basic things I can do with it through the console. Let's go back here. I can simply come here and say CF push. Before we started, I did CF login to log in, right? So it knew where I wanted to put stuff. But it's going to just take my source code, pick that build pack, do its magic, and deploy it. Right?
So you logged into the org?
And when you log in, if you've got multiple orgs, it'll ask you which org you want. Good question. Yes, it will. So while that's running, so this is deployed now. If I go look at my status, should see one pod running here. If I go back to here and I run .NET, send, 2 exclamation points, right? I deployed my change, right? So committing code, ran my pipeline, did all the magic that I configured through that manifest file, right? And deployed it. This does not refresh as friendly as the OpenShift console, so a lot of times you got to hit this. It always comes up in a crash state until it gets past this. So you'll see here it is cleaning up the image. It's removing the SDK and things that it built into the image to actually build it. Much like I did in the multi-stage Docker build, right, where I created with the SDK and then I create a streamlined version for runtime. Now it should be starting. It's running. So if I come over here to Pivotal Cloud Foundry and hit this on my route that's exposed there, simple.NET service, I don't know if you can see that. Right, so it's going to hit that route that I exposed through there. And if I hit it there, now it's running 2 exclamation points, running the same code, right? So big ideas here are, we want to get rid of that environmental hosts, differences across those environments. What platform you choose, I think doesn't matter, right? These principles apply. I want to have a platform that's like an organism, right? It's just living out there and have some way to interact with it and just say, provision this code and here's where I want it to go and how I want it to go, right? I want automatic provisioning and deployment, right? Which is what we got here. And then there was a third that I spaced, but it's on the slide. I think that was it for what I wanted to show.
That's awesome.
Yeah. So if you're for personal deep dives to learn kind of the infrastructure better, do you think it's worth it installing everything locally and then playing with it, or just go to the...
That's a good question. So, yes, it depends is the answer. So Kubernetes now, if you look here at my Docker, if you got a later version of Docker, it comes with Kubernetes now. So Docker had Docker Swarm, which was sort of an orchestration platform, but again, pretty simplistic, used for running smaller workloads. So if I've got an organization or a company that has a pretty small app, Docker Swarm will work fine, right? You don't need Kubernetes for that kind of thing. But they also now have Kubernetes built into their Docker installation by default. You have to go through and enable it. Preferences, Kubernetes right here. Enable Kubernetes. It'll kick and scream for several minutes, and then it'll restart Docker, and then Kubernetes is running. You can interact with kube control right here in your native environment like you would if you installed it yourself, right? Eats a lot of memory. You'll need to come in and bump these things up in order to run Kubernetes, and there's some docs on what I think it's got to be at least 4 gig of memory, and probably more. 4 CPUs is fine. Probably a little more swap space. I don't remember off the top of my head, but you can run Kubernetes here. OpenShift 3, which is now 3.11, there's a version called MiniShift, which you can just install on your desktop and run it, and it's a full-blown OpenShift installation. OpenShift 4 went to CoreOS, and it doesn't run natively like that. So there is no MiniShift for OpenShift 4, which is the latest version. So if you want to do OpenShift 4, you're either going to have to use a hosted platform, like they have an OpenShift Online, which you can get a free account on and do some minimal things, or do what I did and install it into AWS. Use ours, right.
Yeah.
Right, if you're talking about, like,
If you
in
want
our practice. Or you could spin one up yourself, right? However you wanted to do that. The basic installation is pretty simple. If you get much beyond the basic, like changing network policies, using a specific CIDR block, right? There's all kinds of how you want file storage to work, right? If you get beyond the basics, it gets pretty hairy pretty fast. Probably not a great place to start. So I'd start with simple and just kind of work through the things.
You mentioned, I think you mentioned another follow-up after this one. The next
Yeah, so I got a couple of things as part of the epic, right? The next one I think is going to be on automation. How we take these ideas and then scale this to an enterprise, right? Because I'm going to have a lot of, especially if I'm Kubernetes OpenShift, I'm going to have a lot of templates, right? And I don't want to be maintaining those, as I was saying, at an API or a project level. I want something bigger, and then I need something to automate that provisioning and deployment, right? Well, the way I do it is Chef Puppet Ansible, some kind of automation tool like that, right? So I was going to talk Ansible, is what I've been doing most of. How I would look at that scaled deployment from an automation standpoint with Ansible. And then another topic is monitoring. How do I get insight into this environment? Because this is all fairly easy once you get your head around it, right? But where we're struggling is the staff understanding all the moving parts that are under it and being able to react to things, right? If something fails, I'll get notification here, right? I can set it up so I get Slack messages or emails or however I want to alert. But once they go in there, they don't have enough knowledge to look at the basic parts that the console gives them. We need something bigger, right? Prometheus, Grafana, some kind of dashboarding approach, right? So I get a bigger picture and more insight into what's really going on. And I'm serious about it. If anybody missed Docker and wants to start over more basic stuff, just ping me and we'll sit together for an hour and talk about it if you want.
That's great, thank you.